Cool. It says live. I think we're live. All right. Thanks for your patience with technical stuff, everybody. Remote folks, welcome. So for reference, here on the right we have some Haskell code. We'll get there, but let's talk through a few things first, getting started. So I will say, like, I have mostly prepared to present this in the form of, like, I'm assuming you know Ruby and some Rails stuff, and we'll make some comparisons there. I don't think it's super essential, but that is kind of the framework here. Honestly, the big takeaway that I hope people get today is, I'm assuming you have been exposed to some object-oriented programming, and let's talk about functional programming and see Haskell as an example of a functional language. So Ruby folks especially, like, tell me what you know about object-oriented languages. Like, what's this thing about Ruby and how it relates to objects? Everything is an object, right? Literally, like, when you add the number 2 to the number 2, like, both numbers are instances of some integer class, and adding them is a method on that class, and literally every single thing that you do is manipulating methods on objects. So that means, like, as you structure large programs, you do that by building up collections of objects, hopefully collections of small objects that we understand, things like that. But it's all about getting lots of objects to talk to each other. There are lots of things that go along with functional programming, but I'd say, like, the core, like, the thing that distinguishes functional programming is, instead of building up your program by defining objects and defining how they interact, you build up your program by defining just functions, standalone functions, and composing them. Right? Functional programming is a lot about how things compose. That's an abstract notion. It's hard to get across without some examples. We'll see some examples in a bit. There are some other things that are often associated with functional programming. We've talked a lot about immutability. Immutability is very common in functional worlds, but isn't, I don't think, strictly essential. So like, after this is all said and done, we'll take a minute to kind of reflect on what's Haskell specific and what really is functional programming at large. But just kind of getting started here, what I've got over on the right is some Haskell source code. This is all generated from, there's a program called Stack that's very much like Bundler. It's pretty nice to use. It's relatively new. I highly recommend it. And this is just like Stack new, make me a brand new blank Haskell project. Over here on the left, I'm in that project, and I can say Stack GHCI. GHC is the Haskell compiler. I is interactive, so this is like an interactive Haskell session. Think pry for Ruby people. It's something similar. So here we can poke around and just run some Haskell code and check it out. So we can add things. We get numbers back, right? This is a REPL. One of the really, really interesting and different things in Haskell is that everything has a type, and that our programs are very, very aware of the types of things. So one of the things that you'll see me do a lot is talk about those, and like a powerful construct in this REPL is I can ask what is the type of any given thing. This is a little bit awkward to read. This is saying I don't actually know what the number 2 is because Haskell has provisions for treating 2 as either a float or an integer, kind of as you need. So it's saying it's a thing that is numeric. That's kind of how to read that. Let's try a couple early examples. Yeah, so 2 plus 3 is 5. Again, Haskell's all about composing functions, so the interesting thing is, like, there's nothing really special about these built-in binary operations. Plus is itself a function. It has a type. The type of plus is, it is a function that takes a numeric thing and another numeric thing and gives you back a final numeric thing. This is how you read function definitions. It says you plug in one of these, and I'll give you back one of these. So let's try writing our first function. I'm going to call it embiggen. And what embiggen does is it takes a number n and returns n plus 5. I feel like that's fairly intuitive syntax, right? Nothing terribly alien or scary here. We can load this back into our REPL by doing Control-R to reload our modules. And then we'll have this embiggen function available to us. So if I embiggen 10, I get back 15. No surprises there. Can anyone tell me what the type of embiggen is? Well, let's try it out. Embiggen takes a number and returns a number. Right, you give it 10, it gives you back 15. So, like, one important thing to notice here is Haskell will do what's called type inference for us, but we don't have to say what the types of all our functions are. If you use like a Java or something that requires that indication all the time, it's tedious. That said, it really is best practice to go ahead and annotate them. It makes it a lot easier to understand and use about your code. So I will, as a matter of policy, go ahead and write type annotations, even though they aren't required. So here's how I say what the type of that function is. I'm going to specify a little bit and say, like, I'm not going to use this function to add like floats together or anything. So I'm just going to say, like, it's a function that takes an int and gives me back an int. Let's write another one. Let's say triple is a function that takes an int and gives me an int, where if I triple number x, it gives me back 3 times x. Anyone want to take a swing at how to write that? Are y'all awake? Cool, right? Nothing terribly fancy there. If I triple 10, I get 30. No surprises. Here, I think, is the interesting functional shift. Thus far, if you've done like imperative self-programming, you often think about telling the computer what to do, right? Like, when I hand you this number, here's the process that you execute. I think the better way to think through functional programming is to try to just define what these functions are. Like, what does it mean to perform this operation, and let the computer do the work of figuring out how to perform that. Well, I'll come back to that idea with some more concrete examples in a second. But I would not write this function this way. I would write it this way. Right? Not triple is the function that when you give it an x, it does this, but instead triple is the function that multiplies by 3. Right? I'm talking about what the function is, not what it does. It's some shift, but it's a powerful one. Yeah, so let's poke around a little bit here. Let me reload. If I take a look, this triple function is the same. Does work. If I ask for the type of triple, I get the thing that I expect. Everybody good so far? Any questions on anything? Do stop me at any point in time if there are questions, of course. Okay. The powerful thing about functional programming is, in object-oriented programming, everything is always an object, and so you can always, call methods on any variable that you have. The flip side of that is, in functional programming, everything is a function, and so you should be able to compose things together. Right? So I want to look at composability a bit here. Yeah, let's try. So one of the other hallmarks of functional programming is, you want to write small, simple functions that you understand. Obviously, your program needs to do something complicated, so you need tools for building up higher order functions from simpler functions. We have in fact seen things like this before, right? Like, we've seen map. Map is a staple of functional programming, and especially important in Haskell. Here's what map looks like. If I map the function triple over the array 1, 2, 3, 4, I get 3, 6, 9, 12. That's what you expect there. Just a syntax thing, Haskell does have support for declaring lists like that. You'll probably see me use it at some point in time, so just throwing that out there. So here's a question. What is the type of map? Let's think about it. What's the first thing that I plugged into map? It is a function that takes an integer to an integer. What is the type of the second thing that I plugged into map? It is a list of integers. So map is a function that takes a function that operates on integers, a list of integers, and gives you back a list of integers. In fact, there's nothing specific about integers there, right? Map can take any function that takes in a's and gives you b's, and a list of a's, and transform them to b's. Right, so you get this generic map functions useful. One super cool thing about this functional style programming, with these strong type annotations, is you can use those to explore your code a lot better. Like, they're one of my favorite tools in the world is Google. And seriously, it's great. Maybe you forgot what map is, but I want a function that I can give it an array of things and an operation to perform, and it will give me back an array of things. And it will suggest what are functions that can do that. Note, the order is not important, it'll figure out stuff for you, right? That is crazy powerful. We'll come back to that as we're writing some things. Another interesting feature of Haskell simply is you can like partially apply functions. So let's think about this. Map triple is itself a function, right? Like map triple is a thing that I gave an array and gave it back an array. Map triple is a function that takes a list of ints and gives me back a list of ints. And so I can build up my program by sort of saying, like, triple list is the function map triple. And then triple list would be a function from a list of integers to a list of integers. That would work. So that's one useful tool in kind of building up these computations from simple ones. And it's very declarative, right? Like, here's this process, here's this process, here's this process, here's how you build up complicated processes from simple processes. Yeah, questions on that? How are we feeling in general? All right, so I'm gonna have to do a little math, and I apologize in advance. But you know, one of the things that we need to wrap our head around is like some mathematical formalism. Let's look at kind of a pipeline of functions. This is a silly contrived example, but I'm going to call this P0 because I'm going to write a couple of these. What I want to do is I want to take a function that, given a number, it embiggens it and then triples it twice. Easy enough to write, right? Like if I first embiggen, and then I want to take that and triple it, and then take that and triple it. Right, that will work just fine. I think that's right. That seems right. That's probably right, right? So this is fine, but you know, like, as you can imagine, especially as you start chaining together more and more functions, which you do all the time, this gets a little hard to read. Generally, and this is a totally Haskell specific thing, but like generally you don't like these nested parentheses. Like I find those a little bit harder to read. So just some syntax that you'll see. Here is an alternate definition that does exactly the same thing. $sign really is just start a function bracket, or start a parens bracket, and you know where it ends. Right? So it's a little bit easier to read in line, I think. Now that said, again, I prefer not to think about values. I prefer to think about operations. So the way that I would actually write this function is following. Like, forget about numbers that you're plugging in. What this function is the sequence of you embiggen and then you triple and then you triple. Right? That's how I described it to you in words. So I'm going to write that. Do y'all remember function composition from like algebra classes? When you compose two functions together, you apply them kind of right to left. This is the same thing. I don't think that reads terribly well if you're not familiar with that notation, but let's do verify that it does work. If we check that on 10, we get 135. Assume that if they agree on one thing, they agree everywhere. One option that we have that I think maybe reads a little bit better for what I'm thinking is, I swear this is the last one I'm doing for this. Right, I'm thinking of that as applying embiggen first and then triple and then triple. So I'd kind of like to write that. There is an operator that does that. It's 3 arrows, obviously. That's totally what you guess, I'm sure. This is honestly like one of the weak parts of Haskell. There's a lot of just like dense syntax that is rather unguessable. Also, that is not an operator that's available to you in the core library. You have to import it from control.arrow triple arrows, of course. Sorry. But check, it does work.
You can read the one on the right, the computer will still flip it.
Yeah, because in both cases you are describing the function, right? This function is the thing that you get from composing embiggen with triple with triple. This function is the thing that you get from feeding a number through embiggen and then feeding it through triple and then feeding it through triple. Those are describing the same operation, just in different syntax for thinking about it. And that's all well and good, but I think maybe not terribly exciting yet, right? Nobody really wants to write Haskell yet. It's true. No, I think the real power comes when many of y'all have run into, like, how many times have you had a no method error for nil in Ruby code, right? Front end folks, how many times have you seen like undefined is not a function or something like that, right? The cool part about this is what happens not so much when you start hitting functions that all work, like you take integers, you get integers, what can go wrong? The interesting part is what happens when you have functions that can fail. Because I still would like to compose them, and we've seen a lot of situations where like there's either a lot of like really manual bookkeeping that you have to do to get that to work, or you can forget stuff and it won't work and your program will just blow up in production. You cannot make nil errors in Haskell. You cannot do it. Your program will not run if it is possible to have a nil error. And that really, I think, is the compelling part.
Is that like when it compiles the change?
Yes. Yeah. So let's step through that a little bit and see some of the power that adds. Okay, so let me try and write some functions that this is again to be rather contrived, but let me try and write some functions that can fail. Haskell does have a concept like nil. It's nothing, right? You can return nothing to indicate like I have no answer or no response for you. So let me write a smallify function that's gonna divide by 2, but won't, like, only if it's even, right? If it's an odd number, then we can't divide by 2 because they're integers or something. So smallify is going to take another n, and if n mod 2 is 0, again, a little syntax, I'm going to kind of glaze over that, I apologize, but if n mod 2 is 0, cool, then I want to return n divided by 2. Otherwise, I want to return nothing. Right, kind of reasonable, more or less what you would write for this sort of operation. Let me try and reload now. That is an obnoxious and unhelpful error message, which is another one of the weaknesses of Haskell. These error messages could be a little more friendly. This is another one of those situations where kind of being explicit about your types is going to save you some trouble down the road. The compiler is trying to be too clever, and if I can explicitly tell it what I'm expecting out of this function, my life's going to be a lot easier. So what do you think the type of smallify is? It takes an integer. What does it return? It might return an integer, but it might not. And heretofore, that hasn't been a problem, right? Like in Ruby land, if you write a function and think about first. Like sometimes first returns something, but sometimes it doesn't, and whatever, who cares? But Haskell won't let you do that. Haskell says no. I couldn't match the type you expected, right? You said that this function was going to return an int, but the actual type, like the thing that this is returning, is maybe something. Maybe means you might have a value, but you might have nothing. Right? So, and here's the key part. If you have a Haskell function and there is any possibility whatsoever that it might return nothing, that has to be part of the type signature. Like you will always be able to tell by looking at a function whether or not it's possible to get nil out of it. And moreover, like when you go to compose them, the compiler will check that for you. So this is not a function that returns an int. It's a function that returns a maybe int, right? It might give you back an int. And then we have another thing here, right? Like this is saying, there is type mismatch. There's a little bit of boilerplate here. It's a little bit hard to write. But this is saying I could not match the expected type maybe int, right? That this function should return a maybe int, and nothing is a maybe int. Nothing. It's fine. But I could not match that with this. Like this is an actual int. It's not a maybe int. It's an int. So I have to do a little bit of work here, just to say like I do like I really this is the thing. I'm gonna package this up and say like I have something. Here's the syntax for this. We can meditate a bit on that, but I would appreciate it if you just trust me on that one. This is what's necessary to convince the compiler. Sometimes I have a thing. Here's what it is when I have a thing. Sometimes I don't. And here's that situation. So once it compiles, I can run it. Right? If I try to smallify 10, I get just 5. Right? Just 5 indicates this was a successful computation. It returned 5. If I try to smallify 11, nah, can't do it. Like I refuse to divide odd numbers. Good so far? All right. Let's write one more that tries to triple something but gives up if it's big. I will call it triple. So same idea, right? Triple, we're going to hand it a number. It might give us a number back, but it might fail. Fail meaning returns nothing. So here we go. Say triple. I can type. Triple is a function takes a number. If the number is less than 50, let's say, then it returns triple n. I can call other functions here. I also could have tried that in line. That's pretty simple, but otherwise returns nothing. Again, it's going to complain at me slightly, saying this is an honest int. I need to package that up in just if I want to indicate like this succeeded. But with that addendum, we have a set function. So and again, like that triple function itself is not terribly interesting, right? If we try to triple 10, we get 30. If we try to triple 60, it'll complain. I mean, not explicitly, but like that's too big, and it returns nothing. But here's the powerful part. Like, I can't just plug up these functions, right? This does not necessarily always return an int. This must have an int to operate, right? I cannot call triple and pass in nothing. Sorry. Right? It's saying, triple is a function that takes an integer. You passed in nothing. Triple does not know how to handle this maybe not having an integer situation, so I can't do this. If I tried to write a function that was try to triple and then smallify and then triple, that function will not compile. It says, the first argument to smallify has the type. It takes in an int and returns a maybe int, but you're trying to feed it in something that might be nil. And I don't know how to handle that. Like, you have not told me how to handle that. So it's just going to refuse to run. Right? This is the powerful part, right? Like, you cannot be caught unaware by the possibility of having nil, because it is always known long before the program runs. It's actually not too bad to handle, right? Like, there is sort of an obvious thing to do here. What is it? Like, we're trying to chain together a whole bunch of functions that anywhere along the way could just return nothing. The sort of obvious thing to do is to just pass that nothing forward, right? Like, if anywhere along the way you got nothing, fine. The whole thing's nothing. I know Ruby folks, we've run into this, like when you try to call a lot of dot methods over and over again and chain them together, you kind of have to be worried that you get nothing somewhere along the way, or nil somewhere along the way. Yeah, so like I can fix up that problem. Here is one way to write this, and I mostly introduced this to introduce a new notation. So let's define our pipeline here. So some slightly new syntax. This is do notation. Ruby folks, this is not related to the do notation that you're familiar with. Try to differentiate them in your head. Yeah, okay, so what do we do? Well, if the first thing I want to do is triple n, cool, I can do that. What I need to tell Haskell is, like, that might be a value, it might not. Let me, if there is a value, let me unpack that value from out of that just maybe nothing context. So let's say like A is the thing that I get if I try to pull out a value from that. And then let's say B is the thing that I get when I try to pull out a value from smallify, from smallifying that next value. And then C is the thing that I get when I try to pull out value from that next step along the way, and then when all is said and done, I can return C. That's the final result. When I reload that, note that it compiles, which honestly is just a pretty good signal. Like, the fact that everything plugged up end to end means that I'm pretty confident it's going to work. But that in and of itself is a nice relief. So let's try it out. If I run that on 20, I get just 90. Did that do the right thing? Let's see. I don't know. I can't do math. Okay, so if we triple 2, we get 6. If we smallify it, we get 3. If we triple it again, we get 9. That worked out. But if we try a number like 3, 3 times 3 is 9. If we try to smallify that, it's not even, so it failed in that step. If I try to start out with a really big number, it'll fail straight away, and I get nothing. But it all works fine. So I show that in part to introduce new notation, and in part to think about this idea of sequencing things together. Turns out, again, there are other operators for composing functions that might fail. This is the only time that you will hear me say the word monad, but I can import an arrow sort of thing that is aware of this style of chaining and write my pipeline function this way. Sorry, P1. And again, like I like that style. Admittedly, it's dense, right? It takes some time to get used to writing these weird arrow sorts of syntaxes. But it's very descriptive of what I'm doing, right? Like I am feeding values through this sequence of functions and doing it in such a way that if anything fails along the way, I just push that value, that failure value forward. So this should work the same. If I try a big number, I get nothing. Try 1, 2, 3. Right, that's all consistent. And those really are the same function, just different ways of writing them. Any questions on that? No, that's a lot.
Is that more common since you should just kind of maybe prepare for getting nothing no matter what, as opposed to like when would you write a function to not expect, nil? Like I feel like as the program gets more complex, you should maybe just anticipate nil.
Well, like really the big thing with Haskell or any kind of like statically compiled language is you don't have to worry about it, right? Like if the code that is written expects nil, then you should expect nil, and if it doesn't, you don't need to, right? Certainly like we've run across tons of like anytime you try to look up a key in a hash, there's a possibility that you have nothing. So if your program does that anywhere, which most of them do, that introduces a possibility of having nothing that you'll have to deal with at some point. The key thing is this doesn't let you off the hook and doesn't let you forget to deal with it. If it's relevant and like kind of knowing that the compiler has your back means that you don't have to worry about it until the compiler yells at you. It's actually quite nice. Let me do one other thing in the sort of like low-level Haskell world, and then we'll jump over and look at some web development stuff. I want to mention what it looks like doing kind of input-output operations. So let me write one more function that's going to be an echo function. It's going to be a similar style. Here's how you print things. Here's how you get things. And then let's say like something like that. Seem all right? So if I run echo, there's your basic input-output hello world. Some questions here. What is the type of getLine? There's an interesting thing going on here, right? getLine does give you text back, but it has to do something to get that text, right? Like it has to wait for user input. Importantly, I can run getLine twice and get 2 different values, which is not a thing that normal mathematical functions can do. Like one of the other really, really strong guarantees for this type system is kind of like, this is avoidable in some edge cases, but the general rule is the type should encode kind of everything that the function can do. Right? If your function says it takes an int and it gives back an int, it cannot give you back nothing. It cannot go and check the database for information. Right? Anything that the function can do is encoded in the type signature. So getLine is not a function. It is not just a function that returns text. It's a function that does an I/O operation that returns text. What is that? All right. Right. So the type of getLine is an I/O operation returning a string. The type of putStringLine is is a function that takes a string and then performs an I/O operation. So this is another super powerful thing. In Ruby, if you call a function that you did not write, you have absolutely no idea what it's doing. Right? It is entirely possible that somewhere buried in there, there's a system like backticks rmrf / it could delete your entire computer. Probably not going to happen, right? It's not a thing that actually keeps you up at night, but it is possible. I know. Again, this is a lie. This is one of those lies that I tell. But unless someone has done something especially clever, if you look at a function with that type signature, it cannot perform I/O operations. reference. It cannot talk to a database, right? It can't stop and prompt for user input. That's actually a super powerful thing, right? Like one of the performance things we run into in Ruby land is we'll often inadvertently make queries in our templates causing an n+1 error because we don't realize when we're talking to the database. In Haskell, it's impossible to forget when you're talking to the database, right? If you have a pure function, it cannot talk to the database. So again, like it forces you to keep those things in mind. Sometimes it will work, but it will guarantee that the program you end up with is, is doing the right thing. Yeah, I think that's all I'm going to say on that one. We can do a little bit more on I/O if we have time at the end if people are interested. But I'd kind of like to swap over and take a look at, okay, so like here are some really low-level like core concepts, but what does this look like when you go apply it to something like web development and build up like a Rails-style system? So I think we'll switch contexts to that unless anyone has any parting questions here. Hearing none. Okay, so I have a sort of demo project here. This is your standard like microblog clone. I called it Twips. We're making tweets sort of things. This is again just a stack generated. I just did like stack new Twips Yesod. Yesod is Haskell on Rails essentially. So it's just sort of the generate template, and then I added a few things. So I'm going to step through how this is working, but let me fire that all up. So I'll do this. Yesod shipped with a development server that's just like Rails-S. It'll do kind of live reloading of everything. So it'll take a minute to compile. If you notice that like Rails style, there's a whole bunch of project structure. It's a little bit different from Rails, but solving the same sort of problems. So my hope is that this will look sort of familiar. Let's take a look at what it is currently doing. It is currently compiling. Here's another thing that you don't see in Ruby a lot. I have defined a variable that I haven't used. The compiler can detect those things and can kind of help me find dead code that I'm not using and remove it. It's nicey. Notice like there are like auto migrations, like standard Rails conveniences here. Yes. It's trying to do a migration that's not safe and erroring out, and I'm just going to nuke the database and start over. I wrote a Ruby script to generate some dummy data, so we'll do that. Okay. I was playing around with this last night. I did not clean up after myself. So for reference, I do have just a quick Ruby script to generate some faker data and add it to the database. The problem is I need to let the Haskell server create the database, and then I'll run the Ruby thing. Apologies, that's an uninteresting setup. But here we go. Once it's up and running, this is the standard just out-of-the-box Yesod starting page. I have not touched this at all other than to add this kind of like home sign-in bit. I'm just going to go to home. This is all the past tweets. This is the generated dummy data. It's bootstrap, like totally standard. So let's kind of trace through how this is working, right? Rails folks, especially, right, making a GET request to /twips, right? There is some mechanism in place for taking those requests and saying, okay, like I have this incoming request, where does it go? Rather unsurprisingly, in functional world, where does it go means what function handles it. But there is a config routes. I'm saying like this is seriously Haskell on Rails. Here's what the routes file looks like. A little bit different, but if you understand the problem that Rails is solving, I think you can probably intuit what most of this is doing. I will say that like the home R, the comment stuff, like everything above this was all built in by Yesod. The ones that I added were, if you go to /twips/new and make a GET request, that's handled by this thing. We'll go look at that thing in a second. If you go to /twips, you can make either a GET or a POST request, and that's kind of handled by this thing. We'll see that in a second as well. Yes? What's with the R? So there are some technical bits here. But Rails folks, like how there are those path helpers? This type is essentially playing the role of a path helper. This TWIPS-R is a route data type, and it is a thing you can say, like, build me a link that points at TWIPS-R, build me a form that goes to TWIPS-R. So it's just like we need a data type that can express that. So yeah, these functions are defined in handlers TWIPS. Here we go. If you notice, there's actually two. The fact that I can make a get or a post request to TWIPS-R means that there is a get TWIPS-R, and there's also a post TWIPS-R. Right, two different functions to handle what happens when I have a get request, what happens when I have a post request. Let's kind of step through those. This should be roughly in order of complexity. So get TWIPS-R, the way to read this is, it is a handler, right? It is a thing that should be able to receive a request and send back HTML. You could have handlers that send back JSON data just as easily. Here's how it works. I want to get a collection of TWIPs. I get that from running a function that talks to database. This runDB is an IO style function. So TWIPs with authors is a thing that we'll go look at. And then once I have those TWIPs, I will render a default layout from the file twips/index. Here's that. So if you've looked at like Hamlet or front-end folks, built on like a templating language, like a Jade or something. This should look sort of familiar. It's HTML-like. You don't need the closing tags because indentation handles that for you, and there is some support for a few primitive operations right there. Our handler sets a list of TWIPs, and then in our template we can for all over them. This is some pattern matching stuff that's a little bit dense, but the basic idea is I get this list of TWIPs. Apparently, the things in this TWIPs list look like this. This is pattern matching structuring. Everything in this TWIPs list is a pair of a TWIP and the user. The entity just means a thing that's in the database and is saved and has an ID. Like an entity is an ID and then the actual rest of the object. So if I grab out the pair of the tweet and the user, then I render a cell that has the title, formatted date time, and the identity of the user. Sorry, I should mention these models came from big models. Right, like I declare these very much like an active record style model. I say like, here are my tables, here are the columns in them. An interesting thing is that the author ID column on the TWIP table is a user ID. So there are compile time guarantees that I will never try to look up, like find me the post where the author ID is a number that isn't an author ID. It came from somewhere else. There's another sort of error that you cannot make in this world. All right, so we'll look at some more of these, but let's just start with, like, let's try adding some text here. I'm gonna write a little p tag there and make sure that that does work. Note the development server does kind of recompile. And if I reload, I do get hello. All right, so what I'd like to add is I'd like to add a thing where if I say, like, add a URL parameter, I'd like for this to say hello, comma, the URL parameter. Does that seem fair? Like in Rails land, what would you need to do here? Right, like adding that name equals James means there'd be a params name. You'd need to grab the value and then hand it off to the template, and the template like interpolate it in. What could go wrong there? Param might not be there, and that is another one of those mistakes that's easy to make, right? It's easy to forget to handle that case. Let's see what that looks like in Haskell world. Let's say name is lookup get param, I think is the right function. This is your params bracket equivalent. It is telling me now, like, my handler is grabbing this name variable but never using it. Let's use it. These Hamlet templates support Ruby style variable interpolation. Oh, I have an error. This error message is really hard to read, but any idea what it's trying to tell me? Super dense, right? Like it takes a long time to get used to these. But it is saying, I don't know how to convert a maybe text to markup, right? You have handed me a maybe text variable, and I don't know how to turn that into HTML. Really, the conspicuous part there is it's maybe text, right? I might have a name, but I might not, right? That parameter may not have been provided. So I am forced to confront that. What should we do in this case? Design decision, right? Like I'm going to say, like, if we don't have a parameter, it says hello world, but if we do have a name, it says hello that name. Right? The important part is not so much how you fix it. The important part is that you have to fix it. Here's syntax for that. So that's how you grab out potentially maybe values in a template. Or should be, I forgot something. Oh, sorry. The value that you get out of that maybe is n, not name. Okay, and with that, if I reload, if I have a parameter, it says hello James. If I don't have a parameter, it says hello world, and never can the thing crash. How's that seem? Reason left? Questions? All right. What I want to do to finish this up is I want to add 2 features. First, I would like to set it up so that clicking on like this title took you over to like a show page where you look at this. Like these posts all have a title and body, and we can't see the body here. It's just an index listing. So I'd like to implement a page where we can see the body, and then I want to make like change one database thing and take a look at that. So first off, let's set it up so that these are links that go over to some page. I'll point out we don't have a route for this. So again, like pretend this is Rails. What would you need to do at this stage? Yeah, you need a route that will handle, like when I go to /twip/1, I want to grab the twip with that ID, render a template that shows it, all those sorts of things. I guess you should worry about like if you look for an ID that isn't there, 404, and then I want to make sure that this link points at that tweet, or that this is a link that points at that tweet. So let's work through those. Yeah, let's start from the routes, I guess. So in Rails land, what would this look like? You have like twit/ID goes to r. Like you can make a GET request with an ID. The syntax is a little bit different here. The nice thing is these are typed handlers. I know that the thing that I should get here is a twip ID. So I will say that. I'm just going to line those up so it looks a little bit better. Let's just do that and see what it complains about. Overlapping routes, sort of an interesting one. What's the potential problem here? Yeah, nowhere have I said that my twip IDs look like integers. If I have a twip with ID new, then I can't ever get to the new page. So again, like the compiler can't verify that my users can't make an error, and so it won't let me run the program until I fix that. I can say like, hey, I know what I'm doing. I know this is dangerous, but trust me, it's only ever going to be integers. It's fine. Okay, so at that point, I get a not in scope get twip r. Any idea why? This is the equivalent of a Rails like undefined method show for your controller. Right? You have said that this routes to this function, and remember it does kind of compose from the kernel as well. So you said that this routes to this function, but have not defined a function to handle that. Let's do that. So get with R is the function name. It should have type handler HTML. One cool kind of process thing that you can do is if you don't know what to write yet, you can just say like, I'm just gonna error out. So this should define a function. The function won't work, but I can at least verify that like if the types match up. Right. My goal here really is just to get the compiler happy because the compiler is like so clever that if the compiler is happy, it should all work. Slight problem here. Again, the types are a little dense. The thing is, it's saying, like, you told me that this function is a handler that will give you back HTML, but I feel like it should be a function where I give you a TWIP ID, and then it gives you back HTML. And as always, the compiler's right. I said that this was going to receive a particular ID and should do different things depending on what that ID is. So it's a function that receives the ID and then gives you back HTML. So that is the right type. Clearly it's not going to work. If I try to go to TWIPS1, it'll error out with an internal server error. Like the nice thing about Haskell code, though, is if you don't write the word error in your code, you probably won't have 500 errors. Like if the server can run, it should be really like I've had a Haskell app in production for like 3-4 years now. I have had 2 errors in that time, and they're both from things that I knew were bad ideas when I was writing them and shouldn't have written in the first place. It is impressively hard to get a Haskell server to crash. All right, let's write a real implementation here. So this is a function that receives an ID. Here's what it does. It goes and gets TWIP. There is a, I may get this wrong. There's a get 404 function that grabs the database ID thing, pulls the record out of the database, and returns a sends back a 404 page if it's not found. So I'm going to take that, presumably it's found, if not, it'll 404, and then I will render into the default layout another. You can read widget file as template, right? Like I'm rendering a template. What error would you expect to see here? Yeah, I have a template I haven't defined yet. I'll definitely need to do that, and that is what it's saying. Trying to run compile time code called widget file reload on a file that wasn't found. That's what that means. All right, so let me make one. So this will be show.hamlet. These are Hamlet files. Let's just do h1. I'm just going to have it say show for now and make sure that we can get to seeing that show page. Don't worry about populating the content. Oh, sorry. Look away. I'm not in Vim. Good. Okay. With that, let's try it. I am on the show page. Notably, the compiler is telling me a couple things, like I am grabbing a TWIP, but I'm not using it. Right? Like I think our Rails controllers have sometimes accumulated instance variables that got removed from a template, and it's easy not to notice that. You can't not notice that here again. All right, so let's try and actually do something with it. I guess I don't really care what the ID of this thing is, so I'm going to do another pattern match to just grab the actual data value from out of it. And then I have these functions, since I have an author ID and a title and a body, I get functions TWIP title, and let's do a div with class well, TWIP body, TWIP. Also do I'm not going to worry about the foreign key lookup just for the sake of time. just list the ID of the author. Maybe not. Okay, so reasonable enough. Like, it's saying it doesn't know how to show me an ID because again, it doesn't necessarily know that it's an integer. One nice thing is, you might be tempted to do something like get the author with that ID. You cannot run queries from templates. Templates are pure functions. Right? You have to do all of your database access up front. You have to have done the appropriate includes. Like, you cannot make n+1 errors here. Let's do that. I'm going to say this is go back to the database and get the TWIP author ID for that TWIP. And then this is user ident for that user. User ident is like the email username for a user. Oh, okay. Ignore that. And also ignore that. Okay, so apologies for the hiccups there. But notice, it's very clear at this point I am making two queries when I serve this HTML page up. Right? There's no way to really obfuscate that. Here you go. I have the usernames coming from the users table. And we have the full content here. All right, so last thing I want to add on this is I would like for these to link over. So these are coming from the index page. Right, where I have the title, I want that to now be a link. And I want the href of that link to be like something that should, like, I can hard code the string, right? I can say, like, this is twips / whatever ID. But Ruby folks, we've seen that, like, we want a function there, right? Like, if we change our routes around, we want to be sure that we don't have broken links on our site. So we would like to do something a little bit more intelligent here. The nice thing is that, like, those routes files define routes that we can use. I can say something like link to. Here's that. I want to link to TWIP route. There is an issue here. Conceptually, what's the problem? Can I link to the TWIP route? What do I need to know? Yeah, which one am I looking at? Like, I need to know what ID. And that does surface itself, again, reading these error messages is an acquired skill, admittedly. It's saying, you gave me, like, I needed a route. You gave me a function that, when given an ID, will give me a route. Right? Essentially, read this as, you have not provided the required TWIP ID. So I can't mess that up. And I also can't do anything weird, like if I tried to do TWIP author ID for the TWIP. If I try to link to a TWIP whose ID is a user ID, it will say, no, like, you gave me an ID for a user, not a TWIP. This doesn't make any sense. Like, neat that you can do that. That is not a thing that you can ever, like, that is not a guarantee that Rails will ever provide for you. I need the actual ID for this TWIP now, so I'm not going to throw that away. I will just use that. And with that set, I think I should have working links once it finishes recompiling. Here we go. I have links. When I click on them, they go to the right place. And I have strong guarantees about that. Questions on that? Seem okay? Cool. I'm not going to say too much about the other code. I will push this up, and y'all feel free to take a look at it. The other parts, like, there is an existing make a new TWIP. Again, there's some syntax here, but I think that the basic process is pretty understandable. We have a form, right? This form, like, look away from the implementation. by looking at the type, you can see that this is a form where if you tell it the user ID that's making this post and what time it is now, it will give you a form that should be able to validate and save. And here's how I use it. I run the form. If the form was successful, right? If there were no validation errors, cool. Add it to the database, set a flash message, redirect back, all the standard things that we do. If there is an error, right, if this is not the case, if there was an error, then re-render the new page again with those validation error messages. It's the same process, even though the syntax is admittedly wonky. So I'll leave that there for you to look at. This TWIPs with authors is clearly a SQL query. There's a lot of deep magic in how that works exactly, but I think the intent is clear enough.
What kind of database?
Just SQLite. It's just talking to SQLite database. Although, like, it does support, like, with Yesod, it's the same sort of, like, if you point at a Postgres database, it knows how to talk to multiple different kinds of databases without any extra work. It's active record style. Although, again, like, you can't query for the wrong. Oh, yeah, a noteworthy thing here. Looking at this TWIPs bit, that query clearly did a, select from the TWIPs table. Wait, that's not the one. Yeah, when I go to that site, that definitely made this query. How in the world did it know that it needed to look at the TWIP table? Like, where did I say that? Yes. Yeah. Right. If you are getting something with the TWIP ID, that has to be the TWIPs table. TWIP IDs can't refer to anything except the TWIPs table. That's some Rails style magic, right? Like that's neat. But again, like that's just mistakes that you can't make, right? All right. So I'll leave that for y'all to poke around with. Last thing I want to add. So right now, the data model. I do have a working like create a new post thing. I have this dummy login where you can just say your username and you log in. So I'm logged in. I can make a new post. And it does show up, and it shows up as like I posted it, and I can look at it, all this sort of thing. Standard, totally standard. If you look at the models, right, that's all kind of hinging on this association. Right? It says every TWIP belongs to an author. If you look at the SQL that generated that, there is a not null constraint, and if your backend is Postgres, there's a foreign key constraint. Like there must be an author. There's no way for you to have a TWIP that does not point to a real, honest existing author. I would like to change that. I would like to say, like, I want us to start supporting anonymous users. And think about this, like, if you think about a large Rails app that has accumulated all this responsibility over time, if you remove a not null constraint from the database, that means all of a sudden, all of these places in your app where you assumed that you always had something could be none. Like, could be none. Like a change like this on a big legacy Rails app without big test coverage would terrify me. Seriously, there are so many places where things can go wrong. What, if nothing else, what I hope that y'all get out of this today is what having this compiler type system set up in my back lets me do is I can just say, like, okay, I'm going to start allowing for user IDs to sometimes be nil, and shut my brain off and just fix compiler error messages and end up with something that works. So let's walk through that process. Here's the syntax for that. I just say, like, sometimes this column might be null, right? It's not actually using the existing maybe thing, but it suggests the syntax. So let's see what that does first off. Oh, I guess it has not run the migration yet. Yeah, fine. So it's going to complain about some things. And I don't even have to think about where things can go wrong. Let's just, what's the next thing I need to fix? First error, TWIPs, line 10. It's saying, I expected to have a key for a user. That's a synonym for user ID. What I actually have now is maybe a user. What should I do? So, like, how should we fix that? Like, what do we want this to do if we don't have a user ID here? I guess ultimately I would like for this to say something like, right, if I have a user, then show me that user. Otherwise, just say, like, by anonymous guest. So that is what I would like to have there. That tells you that user now should not be user, but instead a maybe user. So yeah, I can do this sort of thing. Right. So now it depends. Is this TWIP author ID nothing? If so, then user should be nothing. Sorry. There are some subtleties here that I have not explained. Let me skip this one and come back to that. Apologies. It's gonna get rid of that for a second. We'll come back to that. There's some syntax stuff that I haven't shown out yet. Let's check some of the other ones. Line 51 is similar. Yeah, I guess we have not really looked at this form, but it is still telling you the same thing, right? It's saying you are trying to generate a TWIP. This function assumes that you will always have a user ID, and you're going to set the user ID for that newly created TWIP to be that user. The thing is, that's the wrong assumption. Like, when I go to create this form, I won't necessarily always have a user ID. So the form needs to change to reflect that. All right. Next, in TWIP's line 25, could not match maybe user ID with actual user ID. The incompatibility here is I'm grabbing this variable user ID from a function that says it always returns a user ID, and I'm handing it into a function that says sometimes it gets nothing, and there isn't inconsistency there. Which one is right? Well, I really want to allow, I don't want to require auth anymore. Right? I want to change that out to a function that would, give me the logged in user if there is one, but not error out if there isn't one. There is a function for that. It's maybe auth ID. All right, next up, line 60. Right, I previously said that I was doing an inner join and getting records where I had both the TWIP and an author, and that I would always have an author, and that I would return said author. That has changed now. What's different now? What do I need to do? I need to allow for the fact that I don't always have an associated author. I do always want to get TWIPs, right, even if they don't have an author. So I need to change this to a left outer join. And then there is another admittedly syntaxy bit that's still going to complain. In line 60, this is like projection operator. It's saying you have an author, pull out, like match on the user ID for that author. This does not reflect the fact that author could now be nothing, but there is a thing that does that. Again, I don't expect you all to understand the fixes. The thing that's important to get across here is that you are forced to fix them. Right? You can go scan for an example of how to do this. Yeah. There's a large class of like RSpec tests that I find myself having to write. Like, what happens when you pass nil to this thing? You don't have to write them. The compiler essentially writes all of those for you, and you really only have to focus on the actual like business logic. How do my things compose? My function signature has changed now. Like I said that this was going to be a query that returned a list of pairs of TWIPs and users. That's now no longer the case. Sometimes it won't have a user. So I should update my type signature to reflect that. All right, next error in TWIP's line 20. When I render the index file, it's saying somewhere in there I have, again, like the expected confusion, like I think I have a user, but I may or may not. Right now, my query results aren't always users. Sometimes they're maybe users. Often you'll use like M as a prefix there. Haskell folks aren't great about naming things, and I apologize for not bucking that trend today. All right, so like there's a lot of things that you might try that you can't do, right? Like now this MU thing may or may not be a user. If I try to just say, give me the identity for this user, right? This is the equivalent of like calling username on nil. Won't let me do it, right? The user identity function needs a user, and what you're handing it is a thing that may or may not be there. So you're forced to deal with that problem here. And that fix isn't bad. Right, if I have a user, again, I'll kind of destructure it. And if I have no user, oh yeah, sorry. Thank you. Cool. And now if I sign out and go post a new post, I have an anonymous post, and nothing is broken. It is remarkable how often, like the second something compiles, it works exactly like you want. I mean, that's not a guarantee, right? Like nothing stops you from writing a not where you should have not had not, or writing your if then else backwards. Right? There are certainly errors that the compiler can't catch. It's not magic. But there are just like so many mistakes, and so many of the most common mistakes that you just can't make. So it saves you a lot of debugging effort down the road. The other nice thing is, like, admittedly, like there are some dense parts here. Syntax is weird. It's an alien way of thinking about things, especially some of like the arrow symbolic constructions are very opaque. But the cool thing is, like, I think the whole power is the compiler is smart so that you don't have to be, right? Like by hook or by crook, get something that compiles. Once it compiles, you can worry about refactoring it, and as long as it continues to compile, it's probably fine. Like I have gotten more like I have worked on the internals of Yesod, and I understand 0% of them, and it has not stopped me from being productive. It is remarkable. I do not feel the same way with Rails. Again, like anytime I try to make a change to Rails internals, I'm like, all right, that probably broke something. I'm going to run the test and hope they're fine. Like, it's just a markedly different workflow. So that's kind of that's my sales pitch for having strong times. Any questions here? I'll do a brief recap on concepts now that we've seen some concrete examples, but anything you want to look at here? We're here. All right, so let's talk a little bit about functional programming. I guess we have not really seen immutability. One of the powerful things here that is not necessarily true of all functional programming languages, but it is certainly true of Haskell is like once you assign a variable, you can't reassign it. It just doesn't make sense, right? Like how many times have we run into an issue that stemmed from you changed an instance variable where you didn't expect to change it? That is not a thing that Haskell allows you to do. That complicates some things, right? Like looping requires having like a loop counter and updating it, and you're just not allowed to do that, right? So like you can't write a for loop. You cannot, which means you have to lean heavily on things like map and filter and stuff, but you have those and they work. Big things I think are like the key takeaway for me. And like there are functional programming languages where you do all of this like writing functions and composing stuff that have like a Ruby style type system, right? That don't have a compiler, don't check stuff at compile time, that are highly dynamic. One of the particular things about Haskell that I think is so compelling though is the type system, right? Like you can't have nil errors because you know if something can return nothing because it's got that maybe type annotation. You have tools. They take some learning, but you have tools for getting things that might return nothing and composing them without completely losing your mind. And you get a lot of power out of looking at those types. Like if you didn't know filter, right? What is filter? Filter is a function that takes a list and takes a function that tells you whether or not you want to grab the thing, right? A function that takes objects and returns true or false and gives you back a resulting list, right? So Those type annotations are just really rich. Find me a function like that. Drop while, take while, and filter are all functions like that. And they're the only ones that make any sense. Right? Any function that you want to do that does something like that is probably some combination of those. So you get lots of powerful tools for kind of exploring the functions that are available to you through those types. And you know for a fact when a block of code could make database queries. I guess a useful performance thing there is if you have a pure function, right? If you have a function that just takes inputs and gives you back outputs and doesn't do any kind of input, doesn't talk to the database, then that function can be run on absolutely any core in your machine. So we have not talked about trying to write concurrent Ruby. It's very hard to do because kind of any Ruby thread anywhere can mutate anything, and verifying that nothing locks or conflicts is really tough. If your programming language knows that all of your functions can run anywhere, parallelizing Haskell code has its complications. It's not easy, but it is markedly easier because you can just say all right, well, I have 4 cores now. Run these functions on cores as they're available. Go, and the compiler and runtime system can handle all that for you. Yeah, I think those are really kind of the big takeaways for me. Yeah, big one is the Haskell compiler is smart so that you don't have to be. I hate that it has this reputation. All this stuff comes from careful study of category theory. There's a branch of mathematics that goes back 100 years and talks about how functions compose, and is the branch of mathematics that came up with words like monads and hylomorphisms and ridiculous nonsense. And it's super cool. It's fascinating. That is my math background. I love that stuff. But I hope that y'all got a sense that you can be plain productive in Haskell and write real stuff that's useful without really understanding category theory deeply. If you do understand category theory deeply, this will let that pay dividends. So don't let me discourage you from that. But sometimes if you look into functional programming world, that there's an academic streak that goes oh, do you want to print something? Let me tell you about a monad. And I hate it, right? You do not need to know all of those to get started here. So don't ever let that discourage you from exploring a language like this. If y'all are interested in looking further, obviously, feel free to talk to me anytime. Of course, I'm happy to talk. There are some really good books. There is a new one that I do not remember the name of off the top of my head that people talk a lot about. The de facto reference for a long time has been Learn You a Haskell. There's a free online book called Learn You a Haskell. It's quite good. That's where I got my start on this stuff. Also, if you're interested in some other languages that are kind of a similar bent, but maybe not quite so alien, front-end folks, I would highly recommend looking at Elm. Elm does a much better job of making those error messages user-friendly. Haskell could learn a lot from that. And if you looked at any kind of React, the React, especially Redux, draws a lot from Elm, which drew a lot from Haskell. Ruby folks, if you're interested in something else in this direction, Elixir is quite interesting. Elixir is a functional language with a very Ruby-style syntax. It does not have a strong type system, so that's a different sort of feel. But it runs on the Elixir VM, so it is quite good for if you need to write an app that's kind of highly concurrent, like a real-time chat app sort of thing, and you like all of the nice affordances that Ruby on Rails gives you, Elixir is a great language for those sorts of problems. Yeah, I think that's it for me. Any parting questions?
What would be the biggest factors if you choosing functional over project, your approaching project?
So for me, I think a lot of these benefits are especially compelling. Admittedly, Haskell makes it harder to write code, right? The compiler complains at you, there's this load up front. The thing is, it makes it way easier to maintain code, and usually that's the hard part anyways. I think Ruby's philosophy is let's make it as easy as possible to write the code that you want. Haskell's philosophy is more let's make it impossible to write the code that you don't want. And so if you're writing a quick one-off script that you're not going to maintain or come back to, there's a lot of overhead and boilerplate work here. Even though it's not as bad as many statically typed languages, there's still a lot of extra work that just doesn't pay off. I think that a system like this with a compiler type and everything is especially compelling if you have a large project where it's so easy with a Rails app to just not have good discipline and not write tests. it is impossible to not have some measure of discipline because the compiler is always 24/7. If you have a large team, maintenance, I hadn't worked on a decade-old, 100,000 line long Haskell app before, so I don't have a direct experience, but all of my experience with language has suggested that, especially if you anticipate a project coming on and worrying about maintainability, it seems like it would let you be very productive. That said, in industry, Haskell, big selling points in Haskell is a strong correctness guarantees, right? It is very hard for you to have some sort of logic error or crash something. The performance is also quite good. It's not quite scene fast, but if you are dedicated about it and spend a little bit of work optimizing it, it will run way faster than Ruby apps will. So it honestly doesn't see a lot of real world use, but where it does see real world use is industries where high performance demands, lots of numerical computation, and also high correctness requirements. So particularly finance is a big one. A lot of finance shops use Haskell stuff. I say a lot, not a lot. It's really not out there nearly as much as I want it to be. But yeah, I think projects like that are especially well suited. Another question? Cool. Well, I will Slack y'all links to all this code. And again, if you have any questions or ever want to look at any of this stuff, always feel free. I will say, I got my start in this, actual hands-on practice with Haskell by reading through Learn You Haskell and then working through project weather problems just to kind of get my head around the syntax. And I found that to be a pretty, Haskell is rather mathematical and fits well on a lot of those problems. So I found that to be a good way to go about it. But if anyone is interested and wants other suggestions, let me know. Cool. Well, thanks, everybody. Don't clap. It's really cool. Thanks, y'all. What do we need to do about the recording?